Alright guys, today we're going to do 2-2 graphing systems of inequalities. We got about 3-ish problems, but we're going to start with a couple of definitions just to make sure you know what a system of inequalities is. So let's start off with that. What it is it is two or more inequalities. So all that means is you can have 2, 3, 4, multiple inequalities, not just one. So we're going to be graphing multiple inequalities. All right, so we are going to use a solid line when you either have less than or equal to or greater than or equal to, and a dash line when you're greater than or less than. Okay, so solid line when you have the equal to parts, the line underneath, and dash line when you don't. All right, a vertical line is when x equals a number. So vertical, remember vertical is up and down. Horizontal line is when y equals a number.
Gary Lucas, if you were in the building or any custodian, if
Sorry,
you
guys.
could meet Sherry McLaren at the Panther.
So remember horizontal is left and right. Vertical is up and down. Okay, so while he's talking, let's just move on. We are going to graph just one inequality first, try that out, and then we'll come down here and graph the system, which is more than one. So remember, when we graph things, this is our slope, so I'm just going to put an M, and this is our y-intercept. Remember, this was, I think, the last thing I taught you guys, is we always start with the y-intercept right at 5. And you do what the slope tells you to do. The slope says go down 2 over 3. Down 2 over 3. And then, because this inequality has the line under it, we know we are going to do a solid line. So let me try to do a solid line here. Okay, there we go. So now, the difference between equal sign and an inequality is that we shade the solutions. Now, for me, I always like to plug in 0, 0 right here. I like to put a little smiley face on him too. So 0, 0, because he's the easiest point to plug in. Now, you can plug in any point that you want. I'm plugging in 0, 0. So for y, I'm going to plug in a 0. For x, I'm going to plug in a 0. And then I'm going to solve this guy. Well, we know 2/3 times 0 is just 0. Now we read the inequality left to right. 0 is greater than or equal to 5. Is that true? Is 0 greater than 5? No, that is false. So that means when it's false, 0.00 does not work. So we do not shade with the 0.00. So I'm going to shade on the other side. And that is your answer. So we always have to check a point. And if that point is false, you don't shade with that point. If that point is true, you're going to shade with it. Okay? Let's try another one. Let's try a system this time. So again, remember a system just has two inequalities. So let's start with this one right here. So here's our slope. Here's our y-intercept. So I'm going to start with the 3. Then I'm going to do what the slope tells me to do. Up 2 over 3. And I'm also going to go down 2 over 3, down 2 over 3. Now let's look at the inequality. It has the underline under it, so I know it is a solid line. Okay? I'm going to get my little smiley face on 0, 0 because, again, I always check 0, 0 because it is the easiest. So I'm going to plug in 0 for y. Plug in 0 for x, and then I have plus 3. Well, 2/3 times 0 is just 0. So is 0 greater than or equal to 3? No, it is not. So we do not shade with the smiley because the 0, 0 did not work. So I'm going to shade on the other side. Okay? Now I'm going to switch pens so that you can see the difference. I'm going to the second equation now. Here is my slope. Here's my y-intercept. So I'm going to start at -3. And I'm going to do what the slope tells me to do. It says go down 4. 1, 2, 3, 4 over 3. 1, 2, 3. Well, I'm off the chart. So let's go ahead and go up 4 over 3. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Now let's look at the inequality. The inequality does not have the underline, so that means that it is dotted. So just kind of do dashed lines. And then again, I'm going to do the 0, 0, so I'm going to check it down here. So I'm going to plug a 0 in for y, a 0 in for x. So again, we know this is going to go away. So is 0 greater than negative 3? 0 greater than negative 3. Yes, 0 is greater than negative 3. So let's shade with the 0, 0. So I'm shading with the 0, 0. Now, when you look at this, you have to find the answer. Now, the answer is where both the yellowish and the purple lie. Those are the answers to both inequalities. So if I look right here, see how I have purple and yellow up here in this little region? That's your answer because over here is just purple, over here is just yellow, and over here is nothing. So you want to find the region where you have both colors. So right here, and I'm going to kind of darken it so that everybody knows that is our answer up there. So what that means is all the points in this little area, all the points will work in these two equations. Okay, what do we think? I think it's kind of fun because shading is kind of fun. All right, let's try again. Now look at number 2's problems and number 3's problems. What is the difference? These are y equals mx plus b. Are these? No, so that sucks if I do that to you. So let's do this first equation. We got to solve it for y. So you see this 3x, it's positive. I'm going to bring it to the other side. And remember, when I bring it to the other side, it makes it negative. Okay? Now I'm going to divide everybody by 2. Don't forget, everybody gets it. So y is greater than or equal to negative 3 halves x minus 1, because 2 divided by 2 is 1. All right, so now let's do it. Here's our m, here's our b. So we're starting at negative 1. We need to go down 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Now let's look at our inequality. It has the line under it, so we know it's a straight line. Okay, again, I'm always going to check the 0, 0, guys. And I always plug it into this version right here. So 0. Then I'm going to plug in the 0 for x. So is 0 greater than or equal to negative 1? 0 greater than negative 1? Yeah, true. Oops, forgot my smiley face this time. So I'm going to shade with the smiley because this ordered pair 0, 0 works. So shading with the smiley. Okay, now I'm going to switch markers. Is this one solved for y? No. So maybe let's try to stick them up here. Okay. This x is positive, so when I bring it to the other side, it's going to be negative. So I have a negative 2y, negative x plus 2. Now here's the big thing. When I divide everybody by the negative 2, what happens to the inequality when I divide by a negative? Yes, it flips. You have to remember that, okay? Because if you don't, you're going to get the whole problem wrong. So I flip that inequality because remember, anytime you multiply or divide by a negative, you flip it. So negative and negative makes a positive. I have 1/2 here. 2 divided by negative 2 is negative 1. So again, here's my m, here's my b. So I'm starting at negative 1, and I'm going up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1, ooh, I can't count, over 2. All right, now let's look at our inequality. Yep, it has the underline, so that means it is a straight line. I am going to check the 0, 0 again, but I'm going to put it down here. So I'm going to plug 0 in for y, 0 in for x. So is 0 greater than negative 1? Yes, true. So I shade with the smiley face. So with the smiley. Okay, and then remember, after I'm all the way done, I look to see where the purple and the yellow are. Okay, nope, only yellow. Nothing, only purple. Woohoo! Purple and yellow right here. So this is the answer, meaning all the coordinates in here fit both of these equations. All right, guys, you have a couple of problems in your practice problem book, so go ahead and try those.